Hello and welcome to a new How to Make 7 Days to Die in Unity video. This one is part 5 I think, and in this one we're going to be making a kind of time management system slash day-night cycle, however you want to call it. So I won't waste any time, we'll get straight into it. This one's going to be a much lighter video after the last inventory system videos that we did, so yeah, it's still going to be fairly substantial but not quite as much of a grueling monster that last one was. So start off, we're going to create a new script and we're going to call it world. If we open up world. Now the thing about world is we need to be able to access it from other parts of the game. Now in Minecraft we did this by getting a reference to the world object from each script that needed to access it. We're not going to do that in this one. In this one we are going to create something called a singleton pattern. So we start off by creating a private static world object which is going to be called _instance, and then we create a public static world which is going to be called instance with a capital I, and this one is going to be a get set, well just a get, and the get is going to just return the above private instance, and then the magic happens in our awake function, and it wants to be the awake thing, it wants to be the very first thing that this does, and what it's going to do that very first time is check if instance does not equal null and instance does not equal this. Then we're going to throw up a little warning and delete this game object, destroy it. So debug.log warning, more than one instance of world present, removing additional, removing additional instance. And then we do the removing, which is just destroy this .game object. And then for the else, if it is null, we just set it to this. So what's going on here is we're creating a static reference that can be accessed anywhere. So even though we don't have a reference to a particular world object, we can access the class of the world object and then access this static reference of instance. And then what's happening is this mono behavior script here is setting that static instance to this mono behavior script. So anything that we put in this script can be accessed, including the mono behavior components, through the use of this static instance. Anywhere else we can just type world.instance and get whatever we want out of it. So we're going to just quickly demonstrate the error. So if I create a new world object here, call it world, reset the transform on it, drag our world script on there, and then I'm going to duplicate it to create a second one. And then also, just while I'm here, I'm going to lower the world generator size to 2 because we're going to be starting and stopping this game a lot and I don't want to have to edit out 3 hours of me just sitting and watching the loading screen. So if I run this now, you can see we have an error saying more than one instance of world present, removing the additional instance, and we only have one instance of world here because it deleted itself. So delete that second reference. The only time we're going to use an instance of it in this particular video is in our world generator script. We're just going to replace here where we set the parent of a chunk after we generated, we're going to use the new world object as the parent, because the world generator script, at some point we're going to be getting rid of it. Well, not getting rid of it, but we're going to be telling it to get rid of itself once the world is generated, because unlike Minecraft where the world continues to be generated on the fly, 7 Days to Die pretty much makes its world and then, you know, breaks out. It's gone, it's done. For now though, we're just going to set the parent to be world.instance.transform, and now if we press play we should find that all our chunks are being placed into the world object. There we go. And there's only 4 of them because I've changed the world size, but that's plenty for this video. We're not really doing anything with the terrain in this video. So now that's done, let's go back to our world script and we're going to start creating our time system. So first off, we're going to serialize field on this one because we want to be able to see it in the inspector, but it wants to be private for security reasons. And it's going to be an int, and it's going to be called underscore time of day, and we're calling it time of day because it will conflict with the Unity time system if we just called it time. So then we need a public version of this, and if you've not used get sets much before, basically this private int is essentially storing the actual value that we're keeping here, but the public access for it is through this, and this allows us to be able to do things like validate the value of the time of day to make sure it doesn't go out of range, or to do other things like, say, if it crosses a certain boundary we can initiate things from in here. So the get part of it is just get return time of day, and that's all that happens there. We're just going to return this value if the value is requested from it. The set part is a little bit more complicated, not much but a little bit. So the first thing we do is set time of day equals value. So whatever value is passed in, if we say time of day equals 12, then value will equal 12. If we say time of day plus plus, then this value will equal time of day plus 1. Now for a little bit of validation, we know that there are 1440 minutes in a day. Now I'm choosing to set this so that one time unit in the code represents one game minute. So you may want to do that differently, that's entirely up to you, but that's the way I'm doing it. So with that in mind, we know that the time should never be greater than 1440 because we're only counting in minutes, and there's no point in going over the amount of minutes there are in a day and then having to divide that to find out the days. We may as well just keep this to the amount of minutes, and then we'll have a separate variable for the amount of days. So if underscore time of day is greater than 1440, time of day equals naught. So it's just wrapping around. It's saying if time of day is greater than the amount of minutes in a day, go back to 0, which is essentially what happens to a clock in a real day. So that's all we're going to do there for now. We're going to be coming back to this. This is going to get quite involved before the end of the video. We'll go down here and we're going to create a new value, and this one is going to be a private float, and it's going to be called second counter, and it's going to equal naught. And then we need an update script. Function, sorry, not script. So what we're going to do here is every frame we're going to increment second counter by the amount of time that's passed since the last frame. So second counter plus equals time dot delta time, and then we're going to keep track of it and say if second counter is greater than 1. When second counter crosses 1, that means that a second has passed since the last time that we did what we're about to do. Time of day plus plus, and then we want to reset second counter. So now if we go back into Unity, we should find we have a public, well, it's not public, it's serialized, but we have a time of day value here, and we can press play and that should start going up a second at a time. So as you can see now, we have a serialized field here, so we can see what the time is, and it's going up at a second at a time. And if I set this to 1438, we should see that it wraps around to 0 once it gets to 1440. So now we'll just create a quick UI element. I'm going to use TextMesh Pro, so that means importing TextMesh Pro. We've gone through this a few times in various videos, but you just click import TMP Essentials. It doesn't take long. You don't need to import the examples and things. And for the most part, it works like regular Unity. It's just a bit nicer to use. So I'm going to call this clock, and we want to put it above the loading screen. I'm going to disable the loading screen for now. We don't need to be seeing that for this video. And we'll just to give us something proper to look at, I'm just going to change that to 0, 0, 0, 0, just so we have a better idea of how it's going to look. Font size, I'm going to say 26. I'm going to make it bold, middle aligned, center aligned, top and bottom. I want it to be aligned at the top but stretched full width. Set its pivot point to be at the top of the box, and then we can set it to -25. And again, you can, these values are entirely average. You can set these to whatever you want, and that should do. So we'll go back into our world script. We're going to need to get a reference to the TextMesh Pro namespace, and then we want to get a reference to the TextMesh Pro object that we're using. So public TextMesh Pro UUUU clock. And then in here, inside of our time of day variable, we can just say clock.text equals time of day dot to string. And then that means that anytime our time of day value is changed, our clock UI element here will be updated automatically. So let's just find world, drag our clock element in there, press play, and there we go. It's updating once a second because that's how often we're updating the value. Now obviously this minute timer isn't much use in the game, so we want to make it look a bit more like a clock. So let's do that next. So we'll create a new function, a private void update clock, and we're going to replace this line here with a call to update clock. And in here we're going to create an hours value, which is going to be equals time of day divided by 60. And we're going to create a minutes value, which is going to be time of day minus hours times 60. So another way you can think of this is we're taking away the whole numbers. So if it was 5 hours and 40 minutes, we're taking away the 5 to get the minutes value. So we set the clock text value by saying equals string.format, and then the format is going to be 1 value, 2 value, and then we're going to say hours.toString, And we're going to pass in a parameter here, and that parameter is D2. And what that does is it means that this number, hours, will always be represented as 2 digits. So if the number is 1, it will say 01. If the number's 12, it will say 12. But if it's only 1 digit, if it's 1, 5, 7, 9, it will say 01, 05, 07, 09, etc. You get the idea. And then exactly the same for minutes. So if we press play now, we should find that we have a more functional looking clock. There we go. And if I set the time forward, let's say 800. There we go, it's 1 o'clock. Or 20 past 1, you get the idea. So now we're going to do days, and days is nice and simple because in 7 Days to Die, they don't break things down into weeks and months that I don't think they do, that I'm aware of. So we only really need to keep track of one number for days, and we don't need to do any validation on it. So we can just say public int day. I'm pretty sure it starts on day 1. If I'm wrong in any of this, just let me know. But hopefully it shouldn't affect you understanding the code if I'm wrong about some of the minor details about how 7 Days to Die work. And then if we go back down to our time of day, and we have this if statement here, we're going to expand this if statement. And all we're going to do is if it rolls over to 1440 and goes back to 0, we then increment the day value, and that is it. I mean, that is how we keep track of days. And we'll just get it to display that as well. So if we go down here, then we're going to say day, and then we want time. I believe this is how it's laid out in 7 Days to Die. And then we just want to add that second value, day.toString, and we don't need to do anything with the number there. If I press play, we should now have a day in our time clock. There we go. And if I increment the time to 1436, we should find the day increments with the time. There we go. This should be actually 1439 because otherwise it's going to 1441, which is technically the first minute of the next day. So now we're going to create a way of speeding up and slowing down time. So above here, we're going to say public float clock speed, set to equal 1 by default. Now we're going to give this a range control, but the thing about this value is the higher the number, the slower the time goes. So we'll just go down here to explain how it works. I'll just replace this value now actually while I'm here. So this value here, every time second counter gets higher than this value, that essentially ticks the time over another minute. So if this value is higher, it takes longer for this to tick over to another minute. If it's shorter, it ticks over, the minutes tick by faster. So this value here, the lower it is, the faster time goes. So with that in mind, we're going to put the range value back to front. So we're going to say 4F to 0F. 0F basically means that every frame a minute will pass by. So if you're running, think about that, you're running 50 frames per second, 60 frames per second. That's how many minutes will go per second. So now we should find we have a range value here. If I press play, I can speed it right up, or I can slow it right down to the point where, well, that's going to be a 1 minute every 4 seconds. So now let's add a little bit of code to keep track of hard nights. So at the top here, we're going to create another public int, and this int is going to be called hard night frequency. And by default, we're just going to set it to 7. And then we're going to create a bool. And the bool, so instead of having a straightforward true or false, it is hard night, and then we set that bool, we're going to create a dynamic bool that works out if it's hard night based on the current day and the frequency of the hard nights. So public bool is hard night, and then it's going to be read only, so we don't need a set value, we just need a get. And the get value will say if day percentage hard night frequency is equal to 0, return true. And all this is doing is it's dividing the day by the hard night frequency, and if it equals 0, that means it's divided evenly. So if the hard night frequency is 7 and the day is number 5, well, 7 doesn't go into 5 evenly. 7 goes into 7 evenly, so that would return true. 15, again, would not return true. 14 goes in twice evenly, so it would return true. And then we say else return false. And that way we don't need to worry about setting the hard night value. We don't need to calculate whether or not it is hard night. This is all done for us. All we need to do is check this bool, and this bool automatically checks the hard night frequency against the day, and we're good to go. So let's do a little bit more work on our clock, because I'm not sure it's always been the case, but I'm pretty sure recently, at least in 7 Days to Die, when it is hard night, you get a different coloured number in the clock at the top. The day number turns red. So let's do that. So if we go down to where we update our clock, and we're going to create a string which we're going to call day text, and we're going to replace this here with day text, and then under here we're going to set day text. So we'll say if is hard night, day text is going to equal string.format, and then we're going to change the color. We do that with hypertext markup style stuff, so anybody who's coded a web page will recognize this, HTML type coding, or XML, or any other markup language for that matter. And the variable goes there, and then the value is day.toString, and that's that. And then else we just set it to the day number without changing the color or anything. So now if we press play, we can see the day is normal, but if I switch the day to 7, you can see it goes red. Or similarly, if I switch the day to 4, but I switch the hard night frequency to 4, it goes red again. And with it being at 4, if I switch it to 8, it's still red. If I switch it to 9, or 0, there you go. Switch it to 9, it goes off, because it's not dependent on any particular type of hard night frequency. You could set the frequency to any number of days you wanted. So the last thing we're going to do in this video to make things a little bit more visually interesting and to represent our day-night cycle a bit better is we're going to make the sunlight change with the time of day, and this is going to be the trickiest part of this video by quite a long way. So first of all, at some point we changed the color of the background so that we could better see our terrain when it was all grey and straight lines. We don't need that now, but it would be nice to have the sky change color with the sun. Fortunately, Unity's built-in Skybox does that. So if we just find our camera here, go to main camera and switch solid color back to Skybox. So if I highlight our directional light and I rotate it, you can see that it changes kind of like through a dusk into night, and then eventually it will come back out again. So we're going to use that. Things will get more complicated in the future, but for now it'll do. I'm just going to set that to 0. That you would mess around with if you were doing sort of seasons. It sort of changes the angle in the sky, but this is the orbit, is a way of thinking about it. It's just the rotation of the sun, but that's the easiest way I can think about it. So back into world, we need another public reference, and this one we're going to call public transform, public transform sun. And then if we go down to here and inside here, so we're only doing this when a time increments, we can say sun.rotate, and then we want 360 degrees. So that's a full rotation of the sun, 360 degrees. Once it gets around to 360, it's essentially back to 0, divided by 1440, which is the number of minutes in a day, and then we're not doing anything with the other two rotations. Not enough brackets. So what that's doing is dividing 360 by the minutes of the day. So that's the amount of rotation per minute that equals. And then we are rotating the sun by that amount. So if we go back to our game now and press play, well actually before we press play, we're going to want to drag the sun into our script. So get world and grab our directional light and drop it in there. Now if we press play and we increase the time, you can see the sun is off. Now, you may have noticed a slight problem there, which is that the sun set at about 11 in the morning, 12 in the afternoon, which is obviously not good. So it's already getting dark at 6 o'clock in the morning, and it's set by about 10. There's a slight disconnect there, and that is that 0 rotation on the sun is basically equivalent to 4 AM in game time. Like, just roughly, there's no science behind this. I haven't looked into the exact numbers that 7 Days to Die uses, but just visually looking at what the game looks like at 4 AM in game time versus the rotation of the sun, I would say that 0 rotation on the sun, so if I just pull up the directional light, set this to 0, that is about 4 AM-ish. So that's what we're going to work from anyway. Or we're going to work from the start of the day, as in when the horde would end and everything, being 0 rotation on the sun. So if we go back into our world script, we're going to delete this. And what we're actually going to do is we're going to do all this inside of our time of day again. So one way we can do this is we can say sun.Euler angles. So instead, rotate increments it slightly. So if we say rotate 3, it's going to rotate around 3 degrees. Whereas if we say Euler angles 3, it's going to set the rotation to 3 degrees. The reason we're using Euler angles this time is because we're going to be multiplying the value by the time of day every time. And the reason for that is you'll know that in 7 Days to Die you can set the time using the console or using the creative menu or anything like that. If we have it set to modify the rotation, that would be fine. What we could do is we could set the sun to the correct rotation to match the time of day once, and then it would always rotate right with the time. However, the first time the time gets modified, that would all go out the window. So we need to basically come up with an absolute way of setting the sun based on the time of day. So what we can do is we can say time of day minus, so this minus 240, that is 240 is 4 hours of game time in minutes. So 240 divided by 60 equals 4. So that gets us from midnight to 4 a.m. So by offsetting time of day by minus 240, that basically offsets the amount of rotation that the sun is out. So remember I said 0 rotation is about 4 a.m. in terms of appearance. It looks like 4 a.m. in the game. So when it's at 0, it's at 4 a.m. By offsetting this by 4 hours, that gets the sun to the correct place for the time. That took a bit of messing about. And then we're going to times it by, and the value we're going to times it by is that 360 degrees divided by 1440 minutes. However, a bit of calculator work showed that that value equals 0.25f. So we can just put 0.25 instead. And then once again, we're not modifying the other values. So now we have an absolute value rather than a relative value. So we can change the time and it will update the sun's position based on that time every time. So let's just run that and see what happens. So you can see it's automatically updated the sun to reflect the fact that it is midnight. And if we speed up time, we should see it getting daylight about 4 o'clock. That looks right. Now we're not quite out of the woods yet, because if you look, it's still getting dark really early. Like by, what is it, sunset at 4 o'clock or 5 o'clock, which isn't necessarily unrealistic depending on the time of year, but then it's not right for the game, which is what we're doing. We're not going for realistic, we're going for 7 Days to Die. So what's happened there is the rotation is linear, so it's always the same. It's rotating 360 degrees, it's using seconds as an incremental value, so it's always going to be rotating at the same amount of speed. And what that means is that you get exactly half day and half night, and 7 Days to Die doesn't do that. Obviously 7 Days to Die has, I think, is it 18 hours of daytime and then 6 hours of nighttime. So that's why the sun's setting so early. So this is the tricky bit. So go into our world script and start typing all the code. We'll start off, we need a public int day start time. And this is all in minutes, or this is all in game units, which for me are minutes, but you may do things differently. And that's going to be equal, and obviously we can change it, it's going to equal 240, which is 4 a.m. And then we're going to say a public int day end time, which is going to equal 1080. No, it's not. It's going to equal 1360, which is 10 p.m. So these numbers, 60 times the hour here being 22. So 22 times 60 equals 1360. And that's how we come to this value. And obviously if you change that, how you set that, you could have the player set the specific time that the day starts and ends, or you could have them set a range. I think that's how 7 Days to Die does it, where you set how long you want the day to be. But either way, these are the only two values that we need to be able to calculate from in here. Everything else is going to be worked out on the fly. So the next value is private int day length, and that's going to be a get, and it's going to return, and it's going to return day end time minus day start time. And that gives us the length of the day itself. And the next value is going to be a float. And this value is going to be the amount of rotation per game unit, so per minute in this case, that the sun rotates during the daytime. So sun rotation per minute, or sun day rotation per minute. And again, it's going to be a get set deal, or just a get because it's read only. And it's going to return 180 divided by day length. So what we did before is we divided a full 360-degree turn by all the minutes in the day. This time we're dividing half of a turn by the length of the day. So obviously this is not going to be the same as the per night value, because the same amount of turn, 180 degrees, but over a longer amount of time. And then we want to do the same for the nighttime value. Sun night rotation per minute get, and it's going to return 180F divided by, and this time we want to get 1440, which is the length of the day, minus day length, which gives us the night length. And if you wanted, you could make another value to get night length, which would just be returning this value. It's entirely up to you. Now for the fun part. We'll go down to where we did this before, and we've got a lot to type. So the first thing we're going to do is we're going to create a value that is going to store the rotation amount that we're going to use. Now the problem we have is we need to change this bit here. So we're saying rot amount. Now we can't just times the time of day by the rotation amount and then set the rotation amount depending on the time of the day, because if we're timesing, say, 240 times, I think the value works out for nighttime at 0.5. So timesing it by 0.5 is fine up until it changes to daytime, because then it's going to change, it's going to times the whole time of day, including the part of the time of day that was technically nighttime. It's going to times it all by the new value, which is going to completely change the overall value and the overall rotation of the sun. So then what would happen is it would get to, say, 4 a.m. and instead of having a smooth transition into daytime, like the sun carries on rotating nice and smoothly, it would jump and go to a new value, which is not what we want at all. So instead we're going to set all this up here, and we're just going to set this to be the rotation amount. All the code that we're going to need is going to be up here. So the first check we're going to do is if time of day is greater than day start time and time of day is less than day end time. So this is basically, is it daytime right now? Then we're just going to simply set rotation amount to time of day minus day start time, which is our offset. So if you remember before, I'm minus 240 to account for the sun's rotation offset because it's slightly out of whack with the proper time of the day. Like if the sun at 0 rotation was midnight, that would be perfect. We wouldn't need to do this, but because the sun's 0 rotation is roughly 4 a.m, we need to offset that. So we're offsetting it by the day start time, because the day start time is when the sun's going to come up, and then we times that by sun day rotation per minute. So that one's nice and simple because we're working from the 0 rotation at that point. We don't need to do any extra maths. However, for the next one, we need to account for this rotation, because since the sun started rotating, it rotated a certain amount by using this value, and we're about to switch to a different value, but we need to factor in this amount of rotation here. I don't know if I'm explaining this very well. So it's else if time of day is greater than or equal to day end time, and you need the greater than or equal to thing because otherwise you have a value somewhere where it's not set. So right now we're saying if it's greater than start time or less than end time. If that was also greater than end time, then if it was ever end time, nothing would get done. So first off, to factor in this here, we can simply say day length times sun day rotation per minute. So that gets us the full amount of rotation that was done during the daytime. And then we can add the rotation for the actual nighttime that we've done so far. So we add that by saying rot amount plus equals, and we want time of day minus day start time. So that's our offset minus day length, because we don't want to be multiplying the entire day by this new amount, because we've already accounted for the daytime part of the day. Times sun night rotation per minute, and oh sorry, missing a bracket there. And now the trickiest one, because while this is technically the start of the day that we're now looking at, so we've got here, this is the daytime, so this is between the current values we've got set, this is between 4 a.m. and 10 p.m. This is after 10 p.m. but still before the end of the day. So this is basically just covering 10 p.m. to midnight. Now we need to do midnight to 4 a.m. and this is the trickiest part, because the time now has rolled over to 0, but the sun is still in its rotation cycle. So if this was a quarter of the day would have just gone over to 0, but the sun would still have a quarter to rotate before the sun got back to 0. And that's what makes this bit tricky, and that's why we've done it in this order. That's why we didn't start at the start of the day up here and then go to the daytime. So else, and then we're going to say rot amount equals day length times sun day rotation per minute. Not sure why I put a bracket there. And then once again we need to, so that accounts for the rotation that was done during the daytime, which technically is now of the previous day, but it's the same rotation cycle of the sun. So then we're plus equal into the rotation amount, 1440, so the length of a full day, minus day end time. So that gets us the amount of night that there was at the end of the day, which is currently 2 hours, 10 p.m. till 12. And that's going to times sun night rotation per minute. And then finally, we add in the amount of rotation we currently have after all of that. So plus equals underscore time of day. And we don't need our offset this time. And we're just going to times it by sun night per rotation per minute. And that's the rotation since midnight. And now if we go back into our game, fingers crossed, that whole mess of code should work. So we've got a time of day set there. So midnight looks good. Speed it up a bit. You can see the sky getting a bit lighter. Or maybe you can, I don't know. There we go. 4 o'clock looked about right. Middle of the day. And it's starting to get darker now. And sunset at 10 o'clock. And as you can see, it smoothly into the next day. And we could decrease the daytime so that it starts at let's see, 1080, which is about 8 o'clock, 7 o'clock, something like that. We'll find out in a second when he gets back round to that side. It makes the days much shorter, or a few hours shorter even. There we go, sun setting at 6 o'clock. And we're done. That is pretty much it. All that is left to do now is to thank my amazing Patreons. All of you, as always, very, very much appreciated. As are everyone who's not a Patreon, by the way. Anyone who's liked or shared or commented on the videos or has joined the Discord, you're all very much appreciated. But the Patreons, obviously, especially appreciated. And among those Patreons, even more especially appreciated are those who are currently helping at the Sugar Daddy / Mama level, and those are Dave Muldean, Gabrielle White, Michael Gulak, Neil Ranking, Reg Reed, and Professor DJ, long-term serving, very active in the Discord. He's been very helpful to the channel, and he's got a project coming out soon. He's making his own language, basically, so that's something to look out for. And yeah, that's it for now. If you missed it on the last video or on the YouTube post or on Twitter or on Discord or any other places I post it, I have an EP out at the minute. I'll put another link to that in the description. Please check that out if you like music, possibly. And I will see you next time. Thanks again. Bye-bye.